Alright, so this geometry video, our main focus is going to be proofs. So, writing geometric proofs is one of the things people struggle with. I see like people, they don't know how to write proofs, they don't know how to prove something, especially with geometric proofs. Algebraic proofs. If you're used to algebra, proving algebra is pretty easy. So in this video, we are going to be proving the squares of a binomial, squares of binomials, factorization. I've done a video on it in the past, the useful factorizations video, which is a recommended prerequisite to watching this video. And yeah, so let's just do a recap. Squares of binomials is like a plus b. If I just square this, I'll get a squared plus 2ab plus b squared. That's what I'm going to get as a result. And you just expand the binomials to find out. So if I do a plus b times a plus b, I'll get a squared plus ab. These two multiply, plus ab plus ba plus b squared. ab and ba, they're the same thing. Combine them, we get a squared plus 2ab plus b squared. That's what the squares of binomials factorization is. Let's go over here and prove it geometrically. So proving it geometrically, we have what seems to be a square. We have a and b, and we have a and b over here. So we're asked to prove how this is going to work. Well, we notice the area of this is just a squared plus 2ab plus b squared, because we have a plus b over here and we have a plus b over here. So this is just a square. I'm going to write this down. We have a plus b times a plus b, and that's the area of the entire square, which is just a squared plus 2ab plus b squared. Now, how are we going to prove this geometrically? Well, we have several. We have a rectangle. We have a square. This is a square. This is a times a. We have this looks as like a square. It could be a rectangle. We're going to find out. So let's prove this right away. So I'm going to separate each piece, and we are going to find the area of each piece, because if this is true, then that means each piece should add up to the area of the entire figure. So this square part is a times a. This is a squared. I'm just going to label every single area that I find out. This rectangle, this part is a, and this right here is the b. That's a. This is ab. There we have, this is AB. And I'm going to move on to this thing. So this is a square. We have B over here. The B comes from over here. And we have a B over here, and we have a B on top. So that's where the B is, and that's where this B is. And this is just B times B, which is B squared. I'm going to write that down. Now we have a rectangle left. And we have a B on top, which is right here, and we have an A on the side. So this is AB, or BA, however you want to call it. Now we notice that opposites in this part are equal. The area of the opposites are equal, a squared and a squared. So if we rearrange it and put it together, obviously the area of the entire thing is, so this is the area of the square is the area of the square is, I'm going to write it over here. So the area of the entire square is a squared plus 2ab plus b squared, right? Because this is just this product of binomials, this right here. It's a factorization of the area of the entire thing. Now, let's find the area of the square by just adding all of these areas up. So, if I add all of these areas up, I have a squared plus, I'm going to go back, a squared plus, I have an ab over here. I'm going to go back, I have a b squared. And then we have another AB right over here. Now this looks pretty similar to our expanded form, the expansion of squares of binomials. The area of the entire thing is this. If we just rearrange this, we're going to get a squared plus AB plus AB plus b squared. AB plus AB, that's AB times 2, and we write that as 2AB Now we've proved it. Now, how have we proved it? Well, if we take in the area of each separate piece in the square, it adds up to the total area, which is a plus b squared. This is a square. So in reality, let's just forget about this for a second. In reality, this is a square. So this right here is the top is a plus b, and over here it's a plus b. So this is just a square of binomials in itself. In itself, it's just we have a plus b squared. Now, if we add each piece up, that's still equal to this total area, and we see the addition is equal to this. So this is a squared plus 2ab plus b squared. So they're equal because we just found the area of the square in two different ways, proving that a plus b square the entire thing, square product of binomials, the expansion is equal to a squared plus 2ab plus b squared. So hopefully this video is helpful. This is just for general proof. I just gave an easy example of how you can use geometry for algebra, or algebra for geometric proofs. And it's pretty easy. We use geometry for an algebraic proof, but you can also use algebra for geometric proofs. And many people struggle with this, so whenever you're struggling with stuff, I suggest you know your theorems and stuff, so know your theorems, and apply your concepts that you know in geometry to writing the proof. Hopefully this video was helpful, and yeah.